The third lesson in our periodic table and bonding unit is on ionic bonding. We have two learning targets for this lesson. We want to be able to describe how an ionic bond forms, and we also want to be able to write formulas for ionic compounds. We'll start with number 7, describing how an ionic bond forms. So, whenever we were learning about the octet rule, we learned that when cations form, they lose electrons. So a question that we want to ask is, when these cations do form, where do the lost electrons go? Likewise, whenever an anion forms, we want to ask, where do these gained electrons come from? So just pause the video and think about that for a second. So you've had a chance to think about it, and perhaps you've recognized that electrons aren't actually lost, as in they disappear, and they aren't really gained, as in they come from nowhere. Really, what happens is any electrons that are transferred from one atom, they always go to another. In other words, every electron that is lost by one atom is actually gained by another atom. So whenever we say, for example, sodium loses an electron whenever it forms an ion, that electron really isn't lost. That electron is being gained by another atom, say a fluorine atom, which we say gains an electron to form an ion. Well, it would have to come from another atom. So let's consider the formation of the lithium ion and the fluoride ion. So recall lithium has one valence electron because it's in the first group, and we might represent it like so, where we just use the symbol for lithium, and then the single dot that we draw next to it represents its one valence electron. Recall the electrons that we're really concerned with are just the valence electrons. We recognize that lithium has more than one electron, but we're really only worried about those valence electrons. And we know fluorine, because it's in group 17, has 7 valence electrons. So we might represent it like so, where we use the symbol for fluorine, F, and then we draw our 7 valence electrons. Do notice whenever we draw these electrons, we do want to draw them in a fairly orderly fashion. I think a good way of looking at that is thinking as if the electrons go in a box around the symbol, and we don't put any more than 2 electrons on any side of the box. It makes them much easier to count that way. And we can see very clearly then that fluorine has 7 valence electrons. So we know that when lithium forms an ion, it needs to lose an electron. And likewise, fluorine needs to gain an electron. And so what happens is lithium loses its valence electron to fluorine. It really gives up that electron, and fluorine takes it. So we could represent that by drawing an arrow from lithium's valence electron that you see here going over to fluorine. So what this results in is ion formation. Lithium lost an electron, fluorine gained an electron. So we formed ions. We now have a lithium ion with a 1 plus charge. We have a fluoride ion with a 1 minus charge, because lithium lost an electron and fluoride gained an electron. These ions are oppositely charged. That means they're going to be attracted to each other. We have all heard the phrase opposites attract. Well, it comes from this right here. Opposite charges attract each other. The lithium ion with its positive charge will be attracted to the fluoride ion with its negative charge. This is an ionic bond. Anytime we have an electrostatic attraction between oppositely charged particles, that's what an ionic bond is. So those two ions will be held together because they're attracted to each other. So our next example here, we're asked to draw a dot diagram to show how the compound sodium oxide forms. So notice sodium has 1 valence electron because it's in group 1, and oxygen has 6 valence electrons because it's in group 16. We know that sodium wants to give up that valence electron, and oxygen needs to gain electrons. So sodium will transfer its valence electron to oxygen. And again, we can demonstrate that by drawing an arrow. But notice, though, that oxygen is still short an electron of its octet. It now has 7 valence electrons once it gained the one from sodium. It needs another electron yet. So that tells us we need a second sodium atom. So that second sodium atom can give up its valence electron to oxygen. Now notice every atom has reached its octet. Sodium has lost its valence electrons to fill its outer energy level. Oxygen has gained the 2 valence electrons to fill its outer energy level. And once again, this will result in ion formation. Notice here, we get 2 separate distinct sodium ions, each of them having a 1 plus charge. We don't get one sodium ion with a 2 plus charge because we had 2 sodium atoms and each of them lost 1 valence electron. On the other hand, we get 1 oxide ion that has a 2 minus charge because it gained 2 valence electrons. And once again, those ions will be attracted to each other because they're oppositely charged. Let's take a look at the formulas and names of compounds. So here are these sets of ions formed in the last 2 examples. Here is the one formed by the lithium and the fluorine atoms, and then the sodium and oxygen atoms. Note that if we add up the total charge in each set of ions, it always equals 0. So with the lithium and the fluorine, we have a 1 plus and a 1 minus. Those add together to equal 0. With the sodium and the oxygen, we have a 1 plus, a 1 plus, and a 2 minus. Those would also add together to equal 0. In other words, what we're showing here is that the net charge in any ionic compound is always equal to 0. If we were to write formulas for these compounds, they would be as follows. For the lithium fluoride, it would simply be LiF. Notice we do not include the charges of the ions in the formulas for the compounds. We also always write the cation first. Recall the cation is the positively charged ion, so the lithium goes first. For the sodium oxide, it would be Na2O, where that 2 is a subscript next to the sodium, and it indicates that we have 2 sodium ions. And then once again, the cation goes first. Notice that if we just have a single ion, we don't use a subscript 1. So if there is no subscript, as you can see next to the oxygen, or next to either the lithium or the fluoride ions, that tells us that there's just one of them. Alright, so far we have been able to describe how an ionic bond forms. Now we want to look specifically at writing the formulas for these ionic compounds. So first, some rules for writing the formulas, all of which we've really already seen from the previous examples. First of all, we write the cation first and then the anion. Recall the cation is the positively charged ion, the anion is the negatively charged ion. Secondly, charges on the ions do not appear whenever we write the formulas for the compounds. Finally, we use subscripts to indicate the number of ions other than if there's one. If there's only one, then we don't need a subscript. And then just something to keep in mind, remember the net charge or the total charge on any ionic compound must be equal to 0. So let's see some examples. We're simply asked to write the formula for each compound. First one we have is magnesium oxide. So what we want to do is we want to identify what the ions are going to be in that compound. Well, notice it's obviously going to contain magnesium, and then the oxide refers to the anion of oxygen. Recall that monatomic anions end with IDE. And what you want to do then is write the formulas for those ions individually. So if we do that, that would show us that the magnesium is Mg2+. We know it's 2+ because it's in group 2, so it will lose 2 valence electrons. Oxygen is in group 16. It has 6 valence electrons, so it will gain 2 to get to 8, so it's going to be 2-. So if I look at these charges, I can see that they're going to balance or cancel if I just have one of each of them, because it's 2+ and 2-. So in our formula, we just need one magnesium ion and one oxide ion. That gives us a formula of MgO for magnesium oxide. Next example, calcium fluoride. Again, identify the charges on each ion. The calcium's in group 2, so it will be 2+. Fluoride is in group 17, so it's going to gain 1 electron, so it will be 1-. So here you can see I can't get away with one of each ion, because if I did, these charges would not cancel. The calcium is 2+, the fluoride is only 1-. So in order to make those charges add up to 0, we need 2 fluoride ions. So our formula is CaF2. A couple more examples. Rubidium nitride. Rubidium is in group 1, so it's 1+. Nitrogen is in group 15, so it has 5 valence electrons, so it will gain 3 electrons, so its charge will be 3 minus. Again, think about how many ions you're going to need for these charges to cancel, and when you do, you should recognize that we need 3 rubidium ions, because it's a 1 plus and the nitride is 3 minus. So our formula there is Rb3N. Last example, aluminum sulfide. So again, identify the charges, and this one will be the most difficult of the ones we've seen so far, because aluminum is a 3 plus, it's in group 13, it has 3 valence electrons, it's going to lose those 3. Sulfide is 2 minus, it's in group 16, so it's going to gain 2. Now ask yourself, how many of each are we going to need in order for the charges to cancel? You'll quickly recognize that this isn't quite as easy as the ones we've had so far, because before, either the charges just canceled if I had one of each, or there was one ion that was either 1 plus or 1 minus. That makes it pretty easy. Here, though, I have a 3 plus and a 2 minus. So we're actually going to need multiple ions of each of these ions, the aluminum and the sulfide ions. Our formula is going to end up being this, Al2S3. If you're not sure how we get that, just consider this. If we have 2 aluminum ions, so I have an Al3 plus and another Al3 plus, that would give us a total of 6 plus. Likewise, if I have 3 sulfide ions, so I have an S2 minus, an S2 minus, and a third S2 minus, add all those up, the total is going to be 6 minus. So they would cancel if I have 2 aluminum ions and 3 sulfide ions, because that would add to a total of 6 plus and 6 minus, which would cancel. Alright, this next slide here, there are some practice problems. I'll post the question. Please then pause the video, try to answer it yourself, and then play the video to see how well you did. First question, explain how an ionic bond forms. Please pause the video. Okay, you've had a chance to think about this. Hopefully your answer resembles something close to what I have here. My answer is, ionic bonds form as the result of valence electron transfer between atoms. The transfer causes both a cation and an anion to be formed. These oppositely charged ions will be attracted to each other, thus forming an ionic bond. So make sure your answer includes something about the transfer of valence electrons, that we form ions whenever that happens, and these ions, because they're oppositely charged, they will be attracted to each other. That is an ionic bond. Alright, next practice, you're going to write the formula for each compound. So I'll give you the name of the compound, pause the video, try to figure out what the formula is, and then play and see if you got it right. Alright, our 3 compounds are as follows. I'll let you pause the video and try it on your own. Okay, you've had a chance to try this. So for lithium oxide, we should have Li2O. The reason being lithium is 1 plus and oxide is 2 minus. So that means we need 2 lithium ions to cancel the charge. So Li2O. B, strontium chloride, should be SrCl2. Strontium is 2 plus because it's in group 2. Chloride is 1 minus, being in group 17. So we need 2 chloride ions. And then finally, calcium phosphide should be Ca3P2. Because calcium is 2 plus, because it's in group 2. The phosphide ion would be 3 minus, being that phosphorus is in group 15. And so we need 3 calcium ions and 2 phosphide ions for the charges to cancel. So that completes our lesson on the ionic bonding learning targets. We have been able to describe how ionic bonds form, and we've also been able to write formulas for ionic compounds.